Harry is a felon, Harry.
Yeah. He was married all his life, and his wife passed away, unfortunately, during COVID. Not from COVID, but yeah, the wife was there, and he's also the leader of an old Dixieland jazz band. He's a very good musician. He plays banjo. He's a band leader, and that's how I met his wife. She was a singer in the band, and that's how they got together. And she's cool with it. There's always lots of guys there, coming to visit. It's a bunch of stinky boys, but she put up with us, so she's very nice. Okay, so Yagi stack. So if you can steer these antennas in different directions, that's kind of a spatial diversity, point wherever you want. You can switch them on and off. In fact, there's a picture of a little box called a stack match controller, and you can pick which of any combination of the three antennas. So you can quickly switch directions if you want to focus all your energy in one direction, then with the press of a button, point the other way instantly. You can also choose the optimum height. As you raise an antenna up, a horizontally polarized antenna, the radiation or takeoff angle goes down. So a very high antenna looks at a low angle, which is really good for DX. But if you're trying to work something domestic that's close by, that's not helpful. You want a lower antenna then. So this gives you all those options. You have low antennas, high antennas, and a medium antenna. And you can switch between those. So that's the power of a stack. Obviously, it's a big investment to have these kinds of things, whether you have 2 or 3, sometimes even 4 in a stack. There's a picture in the shack. Converted garage, sort of insulated. It's jam-packed, what can I say? The U-shaped desk there and everything. So there's 6 stations there. 2 of them are Flex 6600s, and there's 4 K3s, plus there's a VHF station. So it goes everything from 160 meters to 1296. Again, is just for contesting. We pack it full of people and just have a good old time there. 5 of the stations can be operated remotely as well. So we can run an entire multi contest with nobody in the station if we want to. Well, you need somebody there to take care of the IT issues and the flexes that crash all the time and things like that. So that's kind of the inside there. That's Greg, KK6PXT, Fireman Greg. You'll see him in a lot of the pictures here, and then Ken standing there. So this is the project. The project was to make this 83-foot tall tower taller, and on top of it, add an 80-meter rotatable dipole. Now, in this case, it's okay. What is it? It's an antenna from JK Antennas. If anyone's considering buying a Yagi these days, look at JK first. They're absolutely, as far as I'm concerned, the best antenna builder anywhere for the HF bands up to 6 meters. This is a model JK801 with a thing called a tornado tuner that allows it to tune to get a better match over the entire band. I'll show you how that works in a minute. The height of this antenna, somewhere above a half wavelength. As soon as you get about a half wavelength, it forms a very nice pattern. Fully developed, it works. It's like a textbook dipole. So anytime you put your dipole up at least at a half wavelength, things are going to start to really sing for you. And the main thing we had to do was extend this tower by another 50 feet. So I had to add another 5-10-foot sections onto it. So this is a picture of the tornado tuner. So the problem is 80 meters is a very wide band. It's like 15% bandwidth. And a simple antenna cannot be resonant everywhere across the band. So and worse than that, this dipole is short. It's only half the length it needs to be. It has some capacity hats on the end. So these are inductors. So you add inductance near the middle of the antenna, and if you add more inductance, it'll operate on a lower frequency. So then that's fine, but if you want to change the frequency, you need to change the inductance. So this is a very clever design. These coils, they're like springs. They have little arrows there, kind of point left and right. And there's a little tiny motor, and it stretches the springs. They go in and out, and that changes the inductance enough that you can tune the entire band. So you remote control that, and it has a little pulse counter, so you know how many revolutions your motor has made, and you can return to the same place over and over again. So it's very repeatable. So that's a tornado tuner, very useful. So now you have an antenna that's not too big, not too unwieldy, and yet it's tunable over the whole band. So why high 80-meter dipole? There's all kinds of antennas you can possibly put up. Well, first of all, it's a very predictable antenna. There's nothing better than this dipole. Everybody understands a dipole, simple, well understood. Mechanically, physically, it's much easier than trying to build a Yagi. You know, there's 2, 3, and even 4 element 80-meter Yagis have been built. They're just ginormous. They're huge, huge antennas, very hard to build, hard to handle. They don't stay up. They collapse in the wind. Total nightmare. So no, we don't want an 80-meter Yagi. That's more trouble, and it's worth stay with the dipole. So what we'll do is compare this with a couple of other 80-meter antennas that already exist at N6RO, namely a 4-square, that's the 4 verticals, and then there's also a couple of wire quads. So the expectation is that this would have very good gain. A horizontally polarized antenna gets an enhancement from the ground. That is, horizontally polarized radiation, the electric field is horizontal, reflects off the Earth. And so at a distance, that adds or subtracts to the primary ray. So it's a little bit like light reflecting off a surface. So at certain angles, you get enhancement. It can be 5 or 6 dB. So that's like having 4 times the power just because you have horizontally polarized antenna. So that's one of the real advantages of H-pole. And we also expect relatively low receive noise. Typically, a horizontally polarized antenna will pick up a little less ambient noise. So that's not unusual. So this is what the patterns look like for these antennas. On the right there is a little diagram of the quads. These are designed by N6BV as Dean Straw. He's the guy who was the editor of the ARRL antenna book for many, many years. And he built a bunch of the antennas there, and he was a regular operator. I operated with him there. So I said some of the gods of antennas and contesting have been at that station for many years. So there's the quad. It's 2 gigantic wire loops. At the apex, it's 110 feet. And their setups are actually reversible. You change the phase between them so they can point 2 directions. And there's 2 of these things. So they're kind of not at 90 degrees to each other. So in azimuth, the blue line is the 4-square. The 4-square has a nice pattern, and you can turn that in 90-degree increments. Nice pattern, has some gain. The quad also has some gain. You can see in the red line. And then the dipole, as it turns out, it actually has higher gain than all of them, partly because it's height and also because it's horizontally polarized. So that's very encouraging. So you may have higher gain than anything we already have. In elevation, the dipole has a decent low angle radiation, which is a typical thing we're looking for. And it's actually similar to the 4-square. Classically, the 4-square was our best DX antenna. The quad is a little quieter on receive. But even better, because this tower is on a hill, like it adds sort of another 20 feet. So it turns out this dipole is well above a half wavelength, and then you start to get a lobe that goes straight up. A certain amount of energy goes straight up. And that's actually useful for stations that are close in. You want to work, stations that are on the West Coast. You don't want to go over their heads. You need some ground wave action, or they call it near vertical incidence skywave. You send the energy up and it comes straight back down again. So the dipole will in fact radiate straight up. So this is very encouraging. So the simulation, this is done in NEC, nice simulation tool. Using the tool, the numerical electromagnetics code developed at Lawrence Livermore in the 1970s. So here's our build team. The main guy there, that's Hector. Hector hails from Mexico, but he also lives kind of a little dual citizen. He also lives down in Yuma, and he's the tower buster. In fact, for the Western United States, he's the only tower buster. There's basically nobody else left in the Western U.S. that does professional tower climbing for the amateur market. Hector is basically it. So we have to arrange months and months ahead for Hector to get on his schedule. He comes with this huge trailer outfitted with everything you can imagine. Sometimes he brings a helper. It's nice when he brings a helper. And he makes the rounds. He comes to all various stations and does whatever needs to be done. Very expensive and worth every penny. Completely professional climber, knows exactly what he's doing, works safely, works fast, works all day and then some, and very, very impressive guy to have on the job. Help from other people, including Roberto was there. John was there. He had some fun in the sun, and some of the other guys who were operators there at RO. So the planning was, I mean, this is a big project. The value of this is equal to, buying a nice shiny new car. I mean, a lot of money went into just this project. So, you have to do some design, take some time, do the engineering behind this thing before this very expensive tower climber shows up. He says, okay, what do I do? Well, we're thinking about maybe, no, you don't do that. You got to have this nailed before, the crew shows up, and make sure you have all your materials, things like that. So there are a lot of trade-offs. You start with a naked tower. What do you want to put on it? Well, what kind of antennas? What heights? How are you going to do the switching to the antennas? How do you control all this stuff? How do you make sure your antennas don't crash into the guys? I mean, there's just all kinds of stuff you have to worry about, the basic design. Then you have to find the stuff. And you go buying tower hardware and you find, it's out of stock, or the prices are obscene. So you try to find the used market and things like that. So there was, a lot of challenges just getting all the equipment needed for this. And so there's a picture of the existing tower. Now, you guys, some of you probably know Chris N6WM and Ian N6ML. In fact, Lee, did you not give them their novice tests? You certainly did for Chris. They're right? Yeah. Lee is nodding. Yeah. So they got their licenses around 2008 or something like that, roughly, and quickly got into the contesting business. So the two of them were up the tower at the time. They actually had fall resting harnesses with the double, what are called gorilla clips that are used to tie yourself off, prevent fall. They weren't wearing helmets. That's a fault. So there's lots of safety equipment you should have when you're climbing a tower. But the two of them were up there, and the rest of the crew on the ground, including not one, not two, but three contest Hall of Famers, were helping to stack that 83-foot tower back in 2011. And that was set up with 10-meter antennas, 3 of those, plus a couple of antennas for 6 meters as well. And on YouTube, if you search for N6RO, you'll actually find some videos of this station, including these guys up on the tower. So comparing old with new, kind of mapping antennas over, when you stretch a tower, you have to move the guys. The guys sort of go in a certain pattern. The manufacturer tells you exactly how this has to be guided. They have to be at certain elevations, and you don't mess with that. This is very carefully engineered. So if there's a set of guys there, you can't very well put an antenna below that because it'll crash into the guys. So it has to be just above the guys. So that kind of drives where the basic positions the antennas will be. So we have 3 10-meter antennas, and then we end up with 2 6-meter Yagis and a couple other things, and the dipole way, way up at the top on the mast. So I did a tower elevation, and this drawing, everything's to scale. This is to check the guy clearance, make sure there's no issues of any antennas swinging over and hitting a guy. It's used to come up with all the parts that you need. There's lots and lots of hardware associated with the tower itself. I had to come up with cable lengths. All the cables had to be prefabricated. So this way I knew exactly how long every cable was beforehand, and take your parts list off of this. Yeah, an wise old engineer told me that engineers communicate with drawings, and that was very true. So this is something I could show to Hector before he showed up, and he said, oh, that's what you're doing. Okay, I understand it. That's very helpful because now he knows what we're trying to do. And anyone could look at this and realize, okay, this is where all these things go. Parts list, this is the shopping list. Trying to keep track of everything. The missing column here is, of course, the cost. The part you don't want to look at. There's some really expensive hardware out there, and they see you coming when there's only one source for some of this very specific tower hardware. And we shop around a lot. But anyway, you do have to list all this stuff because we ended up short one little piece of hardware. It was one of the grips that goes on the end of a guy. We were short one because they had shipped, 14 out of 15 or something like that. And we're like, oh crap, what do we do now? So you call them up. Yep, they had one. It comes FedEx the next morning. That kind of. Well, you don't want too many little problems like that because that'll stop you dead. So careful inventory. I do these cabling diagrams, and these are very helpful because not only for design but also for troubleshooting and installation. And it goes all the way from the shack on the left, for instance, a rotator controller, to a terminal box that's at the base of the tower. You have a bunch of cables go up the base of the tower, and then the cables go up the tower to whatever you're actuating, like a rotator. And this kind of diagram, does anybody here from the lab remember George Metzger? Maybe if you guys remember George Metzger. You worked for George. Worked with George for many years. Yeah, George is the one who got me started on the loop diagrams and stuff. George was a master of this. So I learned well, and these are very effective tools for design and installation. Cable fabrication, you can't be caught short on the cables, literally. You have to have the right cable with the right connectors and the right length, and you have to know exactly where they all go. There's over 1 mile of cable on just this tower altogether, over a mile. So a very careful inventory, figure out the lengths. I shop fabricate everything. These get high potted, they get tested on a network analyzer, labels on both ends, put a cap on each end and tape it up so it's all sealed off. Those little green caps from ABR Industries, we call them connector condoms. The last thing you need is a bunch of grit. Practice safe connection. So the last thing you want is a bunch of grit getting these connectors because it's going to cause corrosion later on if you can get the connector together at all. So when they're all pristine and clean, seal them up, because in the field, the first thing they do is they get dropped in the dirt and dragged around, and it's a disaster if they get dirty. Nice clean connectors. Needed a couple of new guy anchors. Now, this is another little engineering task. Now, I am not a mechanical engineer, I'm not a structural engineer, nor am I a registered PE in California, but I have friends who are. So what I do is the basic calculations for something like this. How strong does this guy anchor have to be? Then I have them take a look at it and confirm that I got it right before we build the stuff. So had some helpers come out and dig some 3x3 by 5 foot deep holes. We have rebar cages fabricated, drop those in the hole. Up comes the concrete pump. We had 6-inch I-beams ready to go, and those are strong enough for this particular job. We had to place those. So again, this is a structural design problem. If you get it wrong, a guy failure absolutely can lead to a tower collapse. Even one guy lost. On these kinds of towers, it almost invariably will collapse the tower. So no, they can't break. This cannot fail. Now, construction, yes. Of course, we picked like the hottest week of the summer. Yeah, that goes without saying. And it's definitely hotter in Oakley than it is in Livermore. It's always hotter up there. It's in the Central Valley. 4 long, hot days. We usually had Hector plus anywhere from 4 to 6 other guys on the ground to help out. The total just for those 4 days, that was 200 man hours put into this project. So step one was to remove everything from the tower. The tower is going to be re-guyed also. So everything was removed from the tower. Every last little scrap of tape, took everything off, clean it off. Step two is you start repairing the things you took off the tower. Repair and test. So there's Roberto doing just a quick ground SWR check on a Yagi. You find corrosion and broken parts. You had the boom is basically snapped on a 6-meter Yagi. Rotators, normally we don't put used rotators back up. Either they're brand new or they're newly serviced. They never put an old rotator back into service. Old cable, most of it just ends up going to the recyclers. The project is far too expensive to waste your time on, putting 40-year-old cable back up on the tower and then having a problem later on. So new stainless steel hardware, the hardware is cheap compared to everything else. Just get it and do that. So we have a nice, clean, empty tower, refurbished equipment as time allows.
Mm-hmm. Back on that element there in the bottom right there, it looks like the two elements are joined. There's a burn section there. What's that?
On the
I see exactly what he's talking about.
This
right here, right?
Yeah.
Oh, that's that's corrosion. That's an old clamp on the elements. Yeah, these got a few years on them. I think these are KLMs, and they were used when Ken got them, like in 1979. So these antennas are, have a long, rich history. So we try to replace that hardware whenever we can with new clamps and screws and things.
Did they just use a gin pole just on the top antenna, or do they use it for others?
It's only necessary in the top.
On the top?
Yep. All right. We'll be able to next. All right, step 3, prep and install new guys. The new guys were primarily of a product called Philly-Strand, which is aramid fiber inside with polyethylene over that. We like those because they're non-conductive. They don't interact with the electromagnetic radiation. So it's Philly-Strand most of the way down, and then good old extra high strength steel near the ground, which is good for in case somebody snags with a tractor or if there's a fire, because Philly-Strand melt and the steel will not. So we use steel near the ground. So all these guys have to be repaired, cut them to rough length, sometimes final length. Just big grips that get, they call them, well, there's different names for these grips. Anyway, they grab onto the end of the guy wire. They go around an insulator and things like that. All that's prepared first. There's Hector with his little red wagon. Then we had to add sections to the tower. And there's Fireman Greg on the right there, manning the winch. So we had a very nice electric winch there. It's got a foot pedal to operate it. And you pull on the rope to adjust the tension on the thing to decide whether or not it's actually pulling. Capstan winch. So it does a lot of the heavy lifting for us. The tower sections have to be carefully inspected. Some of them are used. You have to make sure, a couple of them are bent, and Hector has his way with them to unbend them so they'll actually slip together. And those are hoisted up one at a time.
How do you determine the proper tensile strength of the new cables versus the old ones that were left?
So the cable for the guys, the manufacturer Rome tells you what tensile strength the cables should be for each height. Mm-hmm. So you look up, and normally it's based on the extra high strength steel, and you look and say, oh, this EHS is 10,000 pound breaking strength. Okay, then you go to the Philly-Strand catalog. It's a different material. You look it up. It's like, I want at least a 10,000 pound tensile strength Philly-Strand. So you pick that size. Along with all the other hardware, has to have a similar rating. Yeah, do what the tower manufacturer tells you. Do not do what the tower manufacturer doesn't tell you. That's the prime directive of K7LXC in one of those tower books. All right, so we get the tower sections ready and hoist them up. This is a classic tower stacking. It's a fairly precarious business. This is what killed the guy in Aruba. So you have a gin pole, and anybody doesn't know, the gin pole is a piece of pipe with a pulley on the end, and you bolt it to the top of the tower, so it's sticking up above. So you got a pulley somewhere up above the tower, high enough anyway. And then you tie on to the tower section or whatever it is you're raising, hoist it up, and that'll bring it right over, just about over the top of the tower, and the climber can then position it and drop it into place. You need really good communication with the guy on the hoist, so that he lowers it very carefully, doesn't drop anything. So yeah, it's a pretty hairy job. A guy like Hector, he's built of spring steel. I mean, this guy could, I'm sure he could press 300 pounds or something like that. Totally fearless, but very respectful of the hazard of this job. Then we hoist up a set of guys, clamps the guys on. Realize you're stacking this tower. You go 1, 2, 3 sections. There's no guys. You know, the top of that thing is just waving around in the breeze, and he's up there, and that's where the next guy tie point goes. There's a special piece of hardware that clamps on up there. So that's sort of one of the highest risk moments, you might say, in stacking the tower. You're on this long, precarious thing, and hopefully the wind isn't blowing too hard. Then we start putting the other hardware on there. Now, an interesting problem is you have a Yagi mounted in the middle of the tower somewhere, and we'd like to rotate it. Well, you know, rotators normally are at the top of the tower and they turn a mast, right? Real simple, just turn the mast. Well, that's pretty obvious how that works. Well, what do you do in the middle of the tower? Well, there's 2 ways. One is a thing called a ring rotator. It is literally a gigantic ring that surrounds the tower and driven by a motor. So you bolt your antenna onto this big ring and it spins around the tower. That's a ring rotator. So that's one way to do it. And then you get 360 degrees. The ring is, in fact, a continuous rotation one. Anyway, it rotates around the tower. They're kind of big and they're heavy and they're a pain because when you climb the tower, you have to climb over this thing that's sticking way out of the tower. So instead, we use a thing called a swing arm. It's the garden gate, if you will. And you'll see a couple of pictures that make it a little clearer how that works. But basically, the antenna is out on an arm sticking out from the tower, and that arm swings back and forth. And that's what rotates it. And you get about, 300 degrees of rotation, something like that. You don't cover the full circle, but close enough and good enough for what we're trying to do. So that's what the swing arm is. And those are a couple different levels for the intermediate antennas. There's also fixed arms. We have one antenna that's just fixed in one direction, simple arm, just bolt the antenna on. We line it up with East Coast and we're done with that one. Getting Yagis up the tower. There's several ways to do this, of course. There's always more than one way. This is called tramming. So there's a couple different methods to this too. But basically, you have the antenna is hung on has a sling that's right at its balance point, and that rope goes up to the top of the tower, up to the gin hole or wherever it's going. And then the tower has a couple of tag lines on it, and those are used to steer the antenna. So you have a winch that's pulling it up, and a couple of guys on the ground, maybe one guy that's pulling it down, if you will. And the rope slipping through your hand burns holes in your gloves. I didn't know a glove could be incinerated by these ropes, but it's true, and that really hurts, folks. So you have to finesse the rope when it's going up, and all the time Hector's up at the tower screaming at you. He's a constant stream of F-bombs, quite the character. So he's screaming at you, more or less, faster, slower, whatever. And pay attention. The guy on the tower is the boss. He's always the boss, and you have to do what he says. So eventually we, kind of got a rhythm after, 1 or 2 antennas, and they went up, reasonably well. So, you kind of guide this thing up, and he's waiting for you up there. Finally gets within range, and he's able to grab the thing and get it into position and bolt it down. And these are only 10-meter antennas. When you get the big ones, stuff like 40 meters, you're talking about an antenna that weighs 250 pounds, and it's corner to corner, it's 80, 90 feet and stuff like that. Those are a little more interesting. The 80-meter dipole is kind of an interesting contraption. It's about 60 feet long. It's fairly light. I mean, I can pick it up, no problem, walk around with it. It probably weighs 40 pounds or something like that. It's not bad. That's the tornado tuner, that big white tube there. And Hector has all the stuff that he needs hanging on it, kind of clipped on. If you need a cable or clamps or whatever it is, everything's, ready to go, so that when he's on the tower, he doesn't have to, oh, wait a minute, send up such and such. He doesn't want that. He wants it all in a kit. So when he receives it up there, ready to go, everything he needs is there, nuts and bolts, cable, hook it up, and it's done, all in one operation. So we start off with this dipole pointed towards the tower. And then you kind of see in the picture here, there's once again, it's the tramming job. There's the rope going up to the pulley up at the top of the tower, and that's pulling it up, and he's there holding on the tag line. So it's just kind of going straight up towards the top of the tower. Now, notice this was done with nobody up there. He's on the ground. Well, that's okay. He basically got the antenna delivered to the top of the tower. Then he climbed up there to actually bolt it into place. So it went incredibly smooth. I was like, the guy's done many of these things. The rest of us were like, how the hell are you going to do this? We have no idea. So no, just sit down, shut up, a couple F-bombs later, everything's good to go. No problem. So there he is up at the top of the tower. On the left, he's just kind of bolted the thing in place. Then, and the mast was set down in the tower. Actually, the mast went up with the top tower section. That was the easiest way to do it. The mast is in the tower section already. Instead of, and this is an 18-foot mast. Having an 18-foot mast lifted over the top of the tower and dropped down in, this is like, you're trying to hold the end of this incredibly long thing and guide it. It's very difficult to do. So instead, the mast is sort of pre-installed in the tower when the section was dropped on. Then to raise it up, he has come along. He just gets down there, jacks the come along, pushes the mast up with the dipole up on top of it. And then over the next couple of days, the antennas went up one after the other. Wind in the afternoon was always a bit of a challenge. We tried to start pretty early, get out there, and John was around for a couple exciting antenna launches like that, and went pretty well. Nothing was damaged, nobody got hurt. Everything went in just where it's supposed to go. So I couldn't ask for a better result. So there's Gary, the cable guy, down there. So the cables, once the antennas are all bolted in place, other than the ones at the very top, the cables are brought up in groups. So he'd go to a certain location. Okay, what do I need? I've got a rotator cable. I got those two antennas here. Maybe send me two antenna cables and a rotator cable for this position. So I look at my list, find the ones we want, roll out. You see them there on the ground, rolled out nice and straight, so they aren't tangled. Put a sling on the end, last of the things, and up the cables go. And they all come down the same side of the tower, very nice and neat. And this is how Hector does it. So instead of a bunch of tape and tie wraps and that kind of stuff, everything's tied on the side of the tower with just plain old solid 14 gauge wire. We started using wire like this as twist ties because it never goes bad. The stuff, it lasts forever. The sun, it doesn't care about sun. It's very strong. If you need to change it, you just use more wire, unwire it, whatever you need to do. So he kind of turned this into this parallel array of wires as he finished it off. So it's the most sanitary installation I've ever seen. Looks just like one of the best commercial installations. If you go to a big commercial tower, you'll see stuff like this. They use, well, a lot of times they're doing great big heliacs and they have special clips and clamps, but everything it looks less like a railroad. Everything's nice and straight. Then it's time to connect everything. So there I am down at the junction box. And in the J box, everything's organized the same way. The wires from the shack come in on the left, the ones with the power go out the right, and it's just kind of working from the diagram. This makes it very easy to test things too. If you have a problem, you don't know, well, is it the cable going to the shack or up the tower? You can come out here and do your testing right there at the base of the tower. So this is kind of what stuff looks like when it's all done. There's a typical finished guy anchor, proper safety wires so the turnbuckles can't spin loose or anything like that. The tensioning of the guys is very interesting. There's a gauge that's called a loose gauge that clips on the guy, and essentially it measures the flexion of the guy. It puts pressure on, tries to bend the guy, and the tighter it is, the less it bends. And little gauges will detect that and tell you approximately what the tension is on the guy. So he has a come along with a special kind of a very interesting little cam clamp. It grips the guy, ties it on the guy anchor, and starts pulling on the guy with his come along till he gets the tension you want. And then you finally attach the guy to the turnbuckle, take all the slack out, and last step is just twist up the turnbuckle, and then you're good to go.
Gary, another question. How did he prevent the guys from singing in nasty winds? You know, because that could cause a serious problem. You know.
Yeah, no one bothers to do anything with that. They make a little bit of noise in the wind, but nothing drastic seems to happen with any of these. It's some combination of it may be because of the high tension or something like that. If they sing, it's going to be a pretty high frequency. They don't gallop like power lines do, and power lines are just a catenary, and those start to gallop, and that's why there's some weights at a specific distance from the terminations of the power lines to prevent the galloping. But these don't really get going like that. The other picture shows one of these swing arms. You kind of get the idea now how the swing arm works. You can see the rotator there and that black rectangle. And the black rectangle, imagine if that thing swings, the antenna then is kind of working its way around the tower. That's a typical sidearm. Here's a stack. Here's two antennas. There's a 10 meter and a 6 meter on the same swing arm. They rotate together. And then up at the top, finally, there's our dipole up there, along with another 6 meter Yagi mounted way up the top. 6 meters, you like anything VHF as high as you can, higher, 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 always higher. And there it is, the grand project, all complete, standing proud in Oakley, California.
Is there a strong back on that meter dipole?
No, it just sags a little bit. JK builds stuff nice and strong. Modern Yagi design was perfected in the 1980s. N6NL is the guy Dave Leeson. He's a professor out of Stanford, and he wrote the book it's called Yagi Mechanical Design. And once he did that, the whole world woke up and realized, oh crap, we've been doing it wrong all these years. And so now anybody who pays any attention and is not just building obsolete antennas like high gain, they look at these tubing schedules, things like that, and learn how to build them nice and strong. So they'll have ratings based on the modern wind speed regulations, with ice loading and things like that. They're very conservative. You know exactly what you're going to get, and no funny business to hold it up. Yeah.
On that 80 meter dipole that you have, are there little crufties on that? It looks like
there are. You can see them there. Yeah, those are capacity heads. So there's two ways to shorten an antenna like this. You can add inductance near the middle, or you can add capacitance out at the end. Adding capacitance actually is more efficient, as it turns out. Antennas radiate primarily by current. And so the high current point is near the middle of the antenna. And you'd like to have that current, if you will, spread out over the antenna, not buried in the inductor. That's why like a base loaded antenna tends to be a poorer radiator than one that has a coil farther up the antenna. But the capacity ends on there make a big difference. So it's half the length it needs to be. So the other thing we noticed was there's some heavy rust at the base of the antenna. And the reason is that the sand around there moves all the time. You bury the base of the legs, add some water, and they start to corrode. I noticed, well, there's some spots here where it's trying to corrode through. So this is standard practice. You drill some rebar holes into the base, use the special rebar epoxy, anchor those, build a form around it, and pour up, in this case, 8 to 10 inches of concrete overlay. But you have to surveil and maintain towers. I mean, especially the guys. The guys, if they get near the ground, especially the anchors that go directly into the ground, they rust off right there. And that's how Ken lost one of those towers. It was during a contest. This guy finally decided to part company, and timber, down it goes. The guy is on the air, on that tower, and suddenly realized, oh, my SWR is crap. My hand just faulted. What the heck is going on? He heard something. He had his headphones on. He goes up. Why is this tower like that? Oh, and it took that one, damaged another one while it was at it. And it was all because of a corroded guy. The guy anchor specifically goes into the ground and, it rusted off. So, this kind of maintenance is pretty important. Thankfully, we don't live near the sea. The guys in Aruba, these towers, they rust from the inside out, and you can't see it in that case. So did it work? Yeah, it worked. All the anchors are just fine. The 6-meter stuff, that's been used in the VHF contests. Our tornado tuner was stuck. The darn thing wouldn't move. It's just a little teeny tiny motor, itty bitty little thing. And so I just sat there with a power supply and just kind of gave it not much more than this rated current. I just kind of bumped it a few times, and all of a sudden it started to move. I said, thank heavens, because it's way up there at the top of the mast, and the tower climber was already gone. I said, oh, crap. So, if that happens, none of us are up to, servicing that thing, and that's a problem. And then the less complexity you have up the tower, the better. Oh, did this just die?
Yep, I think the battery just died.
Battery's probably died. Okay.
Tower fell over.
Power fell out. Does this work? Does this work? Test. I'll use that. There we are. We're back on the air. All right. Check your batteries before the contest starts. So we got the tornado tuner working again. So in the dipole, this is the first tunable antenna that this station has ever had. So we had to come up with some procedures for this. And actually, we still haven't got the thing completely set up for remote operation. That's okay. The dipole plays really, really well, astoundingly well, as a matter of fact. And it's now pretty much the #1 choice on 80 meter in the contests. So here's some lessons learned. The complete detailed design, of course, is very valuable. As I said, this is an expensive, complicated project, and it's not a simple little backyard thing that you can take 2 months to finish ad hoc. This is a big focused engineering project here. Prefabricate and test everything possible. So never use an old item unless it's been completely inspected, adjusted, tested, refurbished, something like that. Rotators especially. There's 2 kinds of rotators. The ones that have failed, the ones that will. Yeah. Invest in new hardware, especially stainless steel. Don't forget the anti-seize on the threads so you can actually get it apart. Hector was up there. He has a really nice little electric impact tool, and he's normally able to just stick that on a nut and just let her rip, and it comes right off. Other than that, he also has a Sawzall. So nothing's going to stop Hector. There's something on the tower that's stuck. It's coming off, and it's coming off now. No problem. And that's the reason we like, stainless with anti-seize, because you can get it apart later. It's very important when you're doing a tower project, you understand that the chain of command. The climber is always the man in charge. It's always the captain. You just have to listen to him. Don't argue with him. You have a polite discussion before the work starts about so everyone understands what we're going to do. And then after that, if he needs something, he needs it, and he needs it now. And finally, test everything before the tower climber leaves, because if you have a stuck rotator or your tornado tuner doesn't work, somebody may need to go aloft and go fix that thing. So we got away with it. It was a close one. I think there's one YAG is not a little bit wonky. We'll have him fix this next time out. So those 2 books got passed around there. I referenced that Up the Tower. That's very good. That's from championradio.com. So both those books were written by very well-known, very experienced tower climbers, and they'll give you very good advice. And yes, there will be more antennas. Count on it. Coming up in a month or so, depending on when the hardware arrives, the next task is the other 3 135-foot towers are going to be completely re-guyed and recabled. So I already fabricated all the cable. Ken's buying all the guys and a bunch of other hardware, and that's going to be a knockdown, drag out job. And I'm not sure if I'm up to it anymore. I mean, it was a tremendous amount of work, and we're not getting any younger, you know. So I tell you, make sure Hector brings his helper this time. They definitely could use a helper who knows what they're doing and works well with Hector. So it's a real adventure. All right, that ends today's entertainment. All right, question?
I mentioned corrosion. You've obviously got a lot of value in this and effort. You make any effort with a galvanic system where you bury a sacrificial element nearby and run a voltage?
So the question about corrosion, specifically on the buried guys, there are a number of techniques to mitigate that. You can use additional sacrificial anodes, burying zinc and things like that. There's also the active kind where you actually generate a small amount of current in the proper polarity, thank you, that doesn't encourage corrosion, rather discourages the corrosion, that active protection. These particular antennas here, the good news is that all of these are guyed to posts like that gigantic I-beam that are set in concrete. So these are all, nicely set in concrete, and other than keeping the surface free of soil, if you will, it's highly unlikely that those things are going to corrode down there. Very common guy anchors are like screw anchors, a lot of those, or it's a great big eye with a long shaft that goes down into a buried block of concrete. So now you have that shaft in the dirt intentionally. It's maybe 3/4 inch diameter coming up out of the dirt. And yeah, those corrode off, and that's what caused Ken's other tower to fail. So either you do this extra corrosion protection, active, passive, whatever you do, or at least you inspect it from time to time. And if the thing's going bad, you have no choice but to dig another guy station next to it and move the guys one at a time. It's a tremendous amount of work. Hey, Rich?
So I'm wondering what kind of connectors you use, and I think you said SO, but those are not supposed to be very weatherproof, is that correct?
So the question about what kind of connectors you use. So these are all, almost all PL259s. And no, they're not weatherproof, not at all. So I use PL259s. These are crimp solder. It's a crimp back shell and soldered center conductor. Then the back shell is covered with a very heavy, it's called dual wall heat shrink. That's the so-called adhesive heat shrink. Then inside the connector, you coat it with dielectric grease, like Dow Corning DC4. So dielectric grease, which is hydrophobic. That's inside the connector on the threads and on the center connector. Then the connector is mated. It's tightened with pliers. It goes beyond hand tightened. Then it's appropriately weatherproofed. And the weatherproofing we've been using is first a wrap of classic, it's called rescue tape. It's the self-fusing silicone tape. You can also use, there's a number of products from 3M, splicing tape. These are self-vulcanizing tapes. So that's the first layer. And that really provides the weatherproofing. And then on top of that, you wrap it with good old, vinyl electrical tape. And that is basically to protect it from the sun, from sun degradation. So you do all that, and yeah, they're weatherproof. You take them apart many, many years later, and shiny, new, and clean and dry if you do that right.
So is there something about other connectors, like I think an N connector is supposed to be weatherproof? Why would you not use those additionally, you said? Yeah,
so the question is, an N connector does have some weatherproofing, some moisture resistance. It has a gasket inside that does helps a lot. And there's a lot of commercial installations you'll see, and there's end connectors out, just hanging out in the weather, and they're usually okay. This is a PL259 shop. What can I say? That's what's on the antennas, except for sometimes you'll have, well, especially VHF or UHF, yeah, those will be end connectors. You got PL259s everywhere. It's what they are. And the end connectors are generally okay. It turns out they're right on the edge for power rating because the very small center pins, the same as the BNC, but they're usually okay for high power because this is all full legal limit. And if, in the case of high SWR, if that ever happens, then the current especially, or sometimes, well, especially the current, can start to exceed the rating of an end connector center pin. So it's not always the first choice. There's also the, it's the European connectors I never deal with. The DIN, yeah, the big DIN connectors. Those are very good. They're very expensive, and it's a major commitment to go to those. Yeah, they're weatherproof, very high power, wonderful connectors. But you know, again, they'll break the bank. So the PL259s are not, you know, the world's greatest connector, but the proper installation, especially the tape, the weatherproofing, they hold up fine.
You probably have to tape up the end connectors as well. So.
Yeah, we would tape up end connectors. Yeah, it's funny. Most of the connectors out at RO over the years, no tape, nothing. We're just sitting out in the weather, and you know, you open it up, and well, that's nasty. Try to clean it off a little bit. You know, bang the bugs out of it before you put it back together. Yeah, and then you wonder, you know, why we have problems. We have, you know, some with multiple stations on the air. If one station has an electrical problem, for instance, there's arcing in a connector, that'll generate, you know, broadband crap, and all the other stations pick it up. Say, hey, what are you doing over there? Every time you key up, you know, you knock me out here. What's going on? And that's all you need is just a loose connector somewhere. And of course, there's hundreds and hundreds of connectors at a station like this. And all you need is one that's loose or corroded, and it's a disaster. So when you build a new tower like this, the wonderful thing about that is everything is new. All those connections are new. They're tight, they're weatherproof, they're clean. And that tower is not the problem. It's always the other tower. So this summer, if finished job, they'll all be recabled. And presumably some of these interference problems will go away. I hope. All right.
Thank you.
Thank you.
Okay.